Okay, I will start with an announcement. Okay, so our midterm exam, as I told you last week, will be held either this week or next week. Okay, so basically, based on the agreement of all the lecturers, the midterm exam, the first midterm exam, will be held on next Tuesday, 8 March at 7 p.m. Okay. Jadi UTS 1 itu akan diadakan di hari Selasa minggu depan ya. Selasa minggu depan tanggal 8 Maret, jam 7 malam, jam 19.00 ya, jam 7 malam. Oke, tanggal 8 Maret, Selasa tanggal 8 Maret jam 7 malam. So that's the announcement. Okay, and please wait for the final announcement from Pak Ferry. And later I will relay that message to the group, to our EduNext group. Okay. About the exam, is there any question about the exam? Apakah ada pertanyaan terkait dengan UTS 1 ini?
Sir, I'd like to ask.
Yep.
It's an essay, right, over at EduNext?
Not necessarily over EduNext. Later, the way we proceed for the exam will be announced later. So most likely you have to attend Zoom based on the previous exam. Okay, there will be, we will provide several Zoom classes, and then you will enter the certain Zoom classes based on the announcement, and after that you just follow what the assistant asks you to do. Okay, and most likely if it's online, okay, you have to do the exam on camp. So there are several requirements for the exam like that. And for those who are wondering how the exam will be, most likely it will be just the same as the previous exam. So you can ask your senior about it. Okay. Any other question about the exam? And please try to provide the ballpoint and A4 paper, because we normally use that. Let me check if I have the previous announcement. Any other question? I think I will share with you guys, okay? For just in case, most likely it will be more or less the same. Although there will be a slight adjustment for this particular exam, I believe. Okay, you can see here, okay? This is what we normally do in our exam. So several requirements is you have to attend the Zoom. Then after that, the answer submission, it can be from using MS Form, or it can be using a Google Form normally. Then this one, you are not allowed to leave your table while doing the exam. Okay, you are not allowed to use your cell phone or Excel as your calculator, so you have to bring your own calculator. Okay, you have to on cam. You have to be on cam all the time. This is the previous Zoom meeting for the previous exam. For sure, it will be slightly different as well for this particular exam. Okay, and the problem, you can only access the problem at the time of the exam. Okay, and you have to use a new A4 paper, writing your name, your student ID number, and this one in Bahasa. Okay, but for those who prefer to use in English, yes, we have it as well. The procedure, we have it in Bahasa and in English, so you don't have to worry about that. Okay. Statement of honesty, yes, you have to write like this. Okay, then oh yeah, provide your ID as well, either the your national ID or your student ID. Okay. And this is how you're supposed to submit the answer. Most likely, this file, this guidance, this protocol, we will send it to you at least 2 hours before the exam, so you can study about it first. Okay, and this is the naming of the file, so you have to name your file properly as well. Okay, there is a limit of the file size. Okay, and if there is a problem, you don't have to worry. Okay, if there is a problem when you upload your work, try to email directly to this. Okay, but I'm not sure whether it will be the same or not for this particular exam. But we will provide an email for the emergency situation when you fail to upload to Google Form or the MS Form. Okay. That is the protocol. Okay, so there is a requirement of the camera. That's why it's better for you to prepare for it. Most of the time, you can use your laptop and your own cell phone camera. So use your cell phone camera to make it that all the table are shown like this. Okay. Any other question about the exam? I believe it's clear enough, right? Apakah ada pertanyaan terkait dengan ujiannya? Okay, kalau misalkan tidak ada, okay, if there is no question about the exam, I will use the time, today's time, till 8 o'clock for the review of the exam. And then from 8 o'clock to 8:30, I will use it for our new topics frame. Okay. But first, I want to check with you guys. Is there any problem with our homework? The latest homework. Number 1, number 2, number 3, number 4. Any one of you having a problem with your homework?
Sir, I'd like to ask for number 3.
Number 3. Okay, yep.
So for points A and B, there are no reaction joints, right, sir? I just want to clarify.
Well, what do you mean by reaction joint?
So there's no BX or BY and AY and AX, only 1.6 kilonewton each.
So yes, correct. So basically at A and B, in this case, right, you can just simplify the problem into like this. So basically this is the simplification. Okay. The simplified case, actually, you can make it like this. So basically at A and at B, you can just simplify it by giving a downward force of 1.6 kilonewton each. So like this, 1.6 kilonewton, 1.6 kilonewton. At G and at E, yes, of course, because it's a pin joint there will be Gx and Gy. And this one is, there will be Dx and Ey, like that. The one that is in question is Cf, Df, and Fg. This one. Okay. Basically, you can just use a joint method, or you can use the section method. But for this one, I believe joint method will be much easier. Okay, because this one is a two-force member, right? So basically, at C there will be 1 kilonewton. The member AC there, it will be just under tension only because it's two-force member, right? So this one, I can just eliminate this and replace it with 1.6 kilonewton here. Because member AC is actually a two-force member, and we know the value of the force, 1.6 kilonewton. Okay, so basically this is the problem, and you can start solving it from joint C here. After solving joint C, you can solve this and this. Okay, then after that you can solve for joint F to solve for this and this. That's simple. Okay, Rafi?
Okay, thank you, sir.
Mm-hmm. Any other question about the homework? How about number 4 here? Is there any problem with this one? This one is actually, although this one is a part of the statically indeterminate case, but it's quite straightforward. Why it's straightforward? Because you can solve it using joint methods. Okay, you can solve it using joint methods. You don't have to use a section method, but you can solve it using joint methods. And this particular problem, from the beginning, actually you can see that the some of the members are zero force member. So you can see clearly that BD and DF is a zero force member. BD is zero force member when you take a look at the joint B, and DF is zero force member when you take a look at joint F. Okay, so this one is zero force member, zero force member. So basically, you can start solving it using this particular joint H, to solve for this and this. Then you can solve for joint C and joint G. Okay, joint C to solve for this and this, joint G to solve for this and this. Okay, because DF and BD is 0, the value for AB will be the same as BC. So this one is known as well. Okay, FAB will be the same as FBC. The same for this one. The same for this one. Okay, because DF is 0, the value of FFG will be the same as FEF. Okay, because those two members are collinear, and there is no other member there. Okay, then after you solving for that, you can solve for this particular joint to solve for this and this, AD and DE. Yeah, to answer the problem. Okay. Any other question about the homework? Zakia, do you have any problem with the homework, Zakia? Zakia, apakah ada permasalahan dengan PR-nya?
Enggak, Pak.
Enggak ya, aman. Oke. Silakan jika ada pertanyaan. Kalau tidak ada, saya coba akan mereview ya. If there is no more question, then I will just try to review all the things that will be there that will be included in the exam. Okay, I have prepared one slide. Yeah, this one I have. Stop share. Then share again. Oh. Yeah, I have prepared a slide. I have prepared PPT for our midterm exam preparation. So, actually, this is all the some of the previous exam problem. So there are quite a lot of it. This one. This is the previous exam problem for our first midterm exam. Okay, some of it, I believe I already give it to you guys as your homework. This one, I already give it to you guys as part of your homework. This one. This one as well. Yes, I have give it to your homework as your homework. This one as well. Okay, this one, just now we have discussed for this. Okay, and this is some other midterm exam, previous midterm exam problem. So basically, when we take a look at this, there are three major components of, there are three major topics that will be covered in this particular exam. The first one, okay, the first one is related to the equilibrium. Sorry, not equilibrium. The first one is related to the resultant. Force resultant, moment resultant, and how to move the force and moment like that. Okay, so that's most likely is the first problem. Then, yeah, this is some of the example. Replace the loading system in the figure below by equivalent resultant force and specify where the resultant line of action intersect with the y-axis with respect to point A. Okay, this is one particular problem, which can one problem example on that particular case. Okay, this is not a problem on that. Okay, so it's about force, moment, result. Okay, this is another case. And then the second thing that will be there in the exam as well, it will be about equilibrium. Okay, the equilibrium can be point equilibrium like this. This is the case of point equilibrium. Why I call this as point equilibrium, because in order to solve this kind of problem, what you need to draw is a free body diagram at a point like that. So for this case, the question, the one in question is tension developed in the chord AC required for the equilibrium. So basically, we know the mass here, the mass of the lamp, 20 kilograms. Okay, 20 kilograms multiplied by G like that. Then we can go for the equilibrium at point D. So at point D here, we have equilibrium, and there we have 20 kilogram multiplied by G. In the exam, please use 9.81, okay, meter per second square as your G. Okay, but here in the example, I will just use 10 as our G, 200 Newton, and then we have the tension from DE, F DE, and then we have the tension from CD, F CD. So this is our first equilibrium. We can solve this because it's point equilibrium. That's the difference. If it's point equilibrium, equilibrium at a point, okay, we only have two equations: sigma fx equal to 0 and sigma fy equal to 0. Only those two. Why? Because there will be no use of using sigma moment. There will be no moment arm there. So by using these two equations, we can solve for FDE and FCD. That's the first point equilibrium. Then we can go to the point C here to solve for the other equilibrium, the other point equilibrium. So at point C, what we have is FCD as well, tension. Okay, remember it's supposed to be action and reaction with this one, from the previous one. Okay, FCD. Then we have FAC, tension as well, and we have FBC, tension, FBC, FAC. Okay. This is a point equilibrium as well, and we have two equations: sigma fx equal to 0 and sigma fy equal to 0. But remember, FCD here we already know it from the previous free body diagram, from the first free body diagram. FCD in the second free body diagram, we already know the value from the first free body diagram. That's why we only need to solve for FAC and FBC. Okay. For this particular problem, is there any question? This is about equilibrium. Any question here? Fatima Nadine?
And so far, sir.
Okay, good. Marsha? Marsha Virginia?
Good, sir.
Okay. Zakia? Oke ya, Zakia ya? Nggak ada masalah ya di sini?
Ya, Pak.
So this is one of the problem that can appear in the exam. Okay, point equilibrium. Okay. And then this is another problem example. I'm not sure whether I have already discussed about this or not. This is about equilibrium as well. Have I discussed about this, or have I give it to you guys as a homework? Hello?
Yes, sir. I think we've discussed this before.
Oh, we have discussed about this before. Okay.
Yes.
So I will not be discussing this a little further. Okay. But I just want to remind you. Okay. When we talk about free body diagram, when we talk about either equilibrium case or thrust case, okay, and if we have here, if we have pulleys like this, yeah, like this, and this, okay, and in the problem there, we don't have any information about the pulley size. Okay, so it is safer for us for that case. Although we have the information about the pulley diameters as well, it will be safer for us to just move, okay, to just move the forces which is happening to the pulley to the joint. So basically here, what we're supposed to do is to replace all the forces which is happening at pulley C and pulley D to join C and join D. So later, we only need to deal with the forces which is happening at the joint. So what we're supposed to do is we have to solve what is happening at each joint. Okay, this, and that. Okay, by doing that, we will be able to get the forces which is happening at the joint. Okay, so for example, this is joint C. There is a force going there. There is force going this. Joint D. There is a tension here, here, and going there. This is tension 1, this is tension 2, this is tension 3, tension 3, tension 4. And then from the small pulley, pulley E, here, we will have tension 2, tension 1, and mass multiplied by G. Okay. Using sigma Fy and sigma equal to 0 and sigma moment equal to 0, here, we will be able to solve for T1 and T2. Okay. And I miss a bit here because there is a joint D. We will have reaction force dx and dy there. Okay, so from this particular free body diagram, we have 3 unknowns because T1 and T2 is already known from the first free body diagram. Okay, in the second free body diagram, we have 3. T3, dy, dx need to be solved. And we have 3 equations as well. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. To solve for dx and dy. Okay, then after we solve for that, we can go here. Third free body diagram. I miss a bit as well. There's supposed to be Cx here and Cy here from the joint. Okay, using this one is already known from the previous one. We have 3 unknowns. We will be able to solve it using sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0 to solve for Cx, Cy, and T4. The most important one here is Cx, Cy, dx, dy. Why is that important? Because we want to simplify the problem to just include the reaction forces which is happening at joint. So basically, sorry, my laptop is running out of battery. Wait a minute. Okay. So basically, the simplified free body diagram will become like this. This one will be Ax, Ay. Then there will be F here from the spring, and there will be at joint C and joint D, there will be reaction force, action and reaction from the pulley to the beam. Because it's action and reaction, if the pulley is going like this, in the beam, it will be the opposite direction with the same value. So Cx going to the right and Cy is going down. Here, dx going to the left and dy is going down. Like that. Dx, dy, Cx, Cy is already known before. So what we need to solve is just fx, ay, ax. Okay, that's the thing. Whenever you solve for an equilibrium case or thrust case, when it has a pulley there, try to solve for the pulley first and find the reaction force and move the reaction force to the free body diagram. Any question about this particular case? This one is a equilibrium, a two-dimensional equilibrium. Any question here? Muhammad Hilmi, apakah ada pertanyaan? Cukup dipahami ya? Sudah cukup jelas?
Sudah cukup jelas, Pak.
Saya mau nanya ke Muhammad Hilmi, yang menurut kamu masih perlu direview bagian mana ya? Yang menurut kamu masih lemah, Hilmi?
Mungkin yang indeterminate itu.
Indeterminate case ya, oke. Cuman permasalahan yang kasus-kasus indeterminate itu tuh tidak terlalu sering sih. Contoh kasusnya seperti ini ya, indeterminate case. Intinya sih kalau indeterminate case, coba cari cara untuk menyelesaikan permasalahannya. Seperti bisa dilepaskah? Kalau misalkan jelas-jelas indeterminate itu coba lepas, oke, pisah jadi dua seperti itu. Atau coba selesaikan satu persatu seperti yang permasalahan yang di sini. Gitu ya ilmiah. Memang harus dicoba-coba kalau yang indeterminate problem untuk mencari solusinya. Oke? Sama banyak-banyak latihan. Oke, Ilmi?
Terima kasih, Pak.
Okay, this one is an example of the equilibrium. And this one is another one. This one is the first one, actually. It's part of the first topics that we have discussed. It's about resultant. Okay, it's about force and moment resultant as well as the equivalent force and moment. Okay, I want to review a bit about this as well. Okay, because this one will be part of your exam as well. So we have this kind of problem. At A, with the system is fixed at A. It's a fixed a boundary condition at A. Then we have to replace the loading system here by an equivalent resultant force and specify where the resultant line of the action intersect with the yx at point A. Here, this one. So we have to find the resultant. Okay, for example, we have the one resultant force, and we have to find which location that resultant force is intersecting this particular line. Okay. For this particular problem, how should we solve this? I just need to, I want to review the thing. Okay, Marcellus Mario.
Yes.
How we solve this particular problem, Marcellus? Hello?
Move the force to point A.
Move the force to point A. Yeah. All the forces you mean. Hello, Mario? Mario?
Yes.
Move all the forces to point A. You mean it's like that? Okay. Hello, Mario?
Yes.
So you mean this force P, move it to point A, and by moving force P there will be force and moment at point A. Then this particular 6 kilonewton, we move it to point A. By doing so, there will be a force and moment as well. And the same, we can move this particular force to point A, and there will be force and moment as well. Okay. But first, I believe it will be much simpler for us to just to divide, okay, to divide 5 kilonewton force here into two forces. Because later the distance will be much easier for us to find. So here we have, okay, we have 3 kilonewton horizontal and 4 kilonewton vertical. So now we have 4 forces to be moved to point A. So by moving 8 kilonewton to point A, what we will have later, it will be like this. Okay, 8 kilonewton, we move it to point A. By moving 8 kilonewton to point A, at the same time, we will produce moment as well. So there will be a counterclockwise moment here due to the movement of due to moving force from point B to point A. And the distance there is 3 meters. So we will have 8 kilonewton multiplied by 3 meters. So 24 kilonewton meters. Counterclockwise. Why counterclockwise? Because if we make the point A as the center of rotation, the moment due to force 8 kilonewton, it will be counterclockwise like this. Okay, at A, center of rotation A. Then we can move 6 kilonewton as well to point A. By moving 6 kilonewton to point A, there will be clockwise moment because this A now is becoming center of rotation, and there will be moment like this, rotation like that. Okay, 6 kilonewton multiplied by the perpendicular distance is 0.5 meter, so 3 kilonewton clockwise. 3 kilonewton meter. Then if we move the 4 kilonewton to point A, 4 kilonewton, I move it to point A. The moment arm there will be 2 meters from here to here. And the moment will be clockwise as well. 4 multiplied by 2. 4 kilonewton multiplied by 2. 4 kilonewton meter. And last one is the first 3 kilonewton. The first 3 kilonewton, if we move it to point A, this will be the moment arm. Okay, so we have 3 kilonewton. The moment arm will be 4 meter. And it will be clockwise as well. So it will be clockwise. 3 kilonewton multiplied by 4 meters. 312. Okay. Yeah. 12 kilonewton meter. Like this. So we have all the forces there. What we supposed to do after that, we can sum it up. Okay, we can sum it up. So later what we will have will be like this. Okay, the horizontal forces will be 5 kilonewton, 8 kilonewton minus 3 kilonewton to the left, 5 kilonewton, and 10 kilonewton going down. And then the total moment will be 23 23 Oh, only one. 1 kilonewton counterclockwise. Kilonewton meter counterclockwise. 24 kilonewton meter minus 12 minus 8 minus 3. Okay, 1 kilonewton meter. And the resultant force there, it's supposed to be square root of 10 square plus 5 square. What is that? 25, 100, 125. F is equal to square root of 125. Okay. Equal to 5. Kilonewton. So that is our resultant force. And the resultant line, the intersection with the y-axis, how we supposed to get it? This one, 10 kilonewton, it will not move it further from the y-axis. Okay, because it's already in the y-axis. So what we need to calculate is just this one, 5 kilonewton. Okay, the 5 kilonewton. We have to move the force in a way so it will be still in the y-axis. Okay, but the moment there will be 0. So in that case, I will move it upwards in order to make the moment 0. Okay, and how can we get there? How can we get the distance here from point A? Yeah. I name it as a y-axis. That's the distance. Okay. Y-axis multiplied by 5 kilonewton supposed to be equal to 1 kilonewton meter. So our y-axis will be 0.2 meter. So later, what we will have, it will be like this. Okay, from the bottom here, it will be 0.2 meter. And at this particular point, we will have the force like this, 5 kilonewton and 10 kilonewton. Or we can just replace it into 5 square root of 5 kilonewton, like that. Or we can just replace it with this one. This force, 5 square root of 5 kilonewton. Okay, so this is about the equivalent, force equivalent, and resultant force, resultant moment, and the equivalent force, like that. Okay, for this particular problem, is there any question? Daniel Alexander?
No question, sir.
Hannah Maria Phoebe?
Yes, no question, sir.
Okay. Costanzo, apakah dipahami Costanzo? Halo Costanzo? No, Costanzo is not wrong. Ryan Noval, apakah dipahami?
Paham, Pak.
Oke, kita lanjutkan ya. Let's continue. This is equilibrium case where we have already discussed previously in the in the quiz problem, I believe. This one is our quiz problem. So basically, if we have a problem like this, what we're supposed to do, okay, there are several free body diagram that we can take a look. Okay, so basically, we have three free body diagram. The first one is the beam. Okay, the first one is the beam. In the beam, what we have is like this. There is a tension force here. We call it as tension 1, and there is tension 2 here, and there is a person here. And there is a normal force from the person. Okay, and there is a normal force from the other person. Okay, AY, BY. That's the normal force. Okay, the normal force from the person to those two people to the beam. Okay, now let's take a look at the person A. If we take a look at the person A, I will just draw it like this. Okay, this is person A. There will be AY there. That's the normal force. Okay, the normal force from the beam to the person. So action and reaction with this one. AY there, and then and beside that we have a weight, the weight of the person, 70 kilogram multiplied by G. Okay, please use 9.81 in your exam, but here I will just use 10 and 700 Newton is, and then there will be a tension force there as well. Okay, if we solve for all the pulley here, the tension here will be the same as the tension here, will be the same as the tension here. So the tension which is happening to the pulley on the left side, which is happening on the beam on the left side, T1, will be the same as the tension which is happening on the person as well, person A, T1. Okay, and beside that, if we take a look at the person B, there will be Py, normal force, action and reaction with this one. So that's why the value is the same, but the direction is the opposite direction. And we have 90 kilogram multiplied by G. Please use 9.81, but I will use 10 here. Okay, then T2. Why? Because the tension here will be the same as the tension here will be the same as the tension here if we solve for the pulley. Okay, so those are two free body diagram apart from the free body diagram of the pulley. Okay, those are the three free body diagram. We have the first free body diagram here. This is our first free body diagram. We have the second free body diagram, third free body diagram. Okay, let's take a look on how many unknowns that we have. Okay, the number of unknowns that we have here is T1, AY, BY, T2. Okay, only 4 in total. Okay, only 4 in totals. And how many equations that we have? So this is the unknowns T1, AY, BY, T2. These are the same. So the number of unknowns are 4. Okay, from those three free body diagram, we have how many number of equations? From the first free body diagram, we have sigma Fy equal to 0 and sigma moment equal to 0. So we have two equations. From second equation, second free body diagram, we have sigma Fy equal to 0. From the third, we have sigma Fy equal to 0. So in total, we have 4 equations, so we can solve it. The first that we have to solve is this and this. So we can find the relation between AY T1 and BY T2. Okay, so from this, what we will get is T1 plus AY minus 700 is equal to 0. Okay, so if we want to replace T1 with AY, T1 is equal to 700 minus AY. The same here, we can solve for relation between BY and T2 using sigma F equals 0. What we will have is T2 plus BY minus 900 is equal to 0. Okay, I want to solve, I want to replace T2. Okay, so T2 equal to 900 minus BY. Then we can use those two to the first free body diagram. Okay, to replace for all T1 and T2. Okay, using sigma Fy equal to 0 from the first free body diagram, what we will have is T1 plus T2 minus AY minus BY, it will be equal to 0. So T1 and T2 here, we can replace it with this and this. And the second equation, using sigma moment equal to 0, if I put it at C, okay, equal to 0, sigma moment at C equal to 0, then I will have AY multiplied by 10 plus BY multiplied by 12 minus T2 multiplied by 16 equal to 0. The same, you can replace T2 here with this one. So at the end, you will have two equations which only have AY and BY. That's why you can solve for AY and BY to solve for the first equation, to solve for the first question. And then using that, in these two equations, you can solve for the T1 and T2. Sorry. By solving AY and BY, you actually solve the B first. And then, after you solve for AY and BY, you can solve for T1 and T2 using these two equations to solve for question A. That's the thing. Okay. Hilmi, saat kuis kemarin kamu bisa menjawab waktu itu? Halo, Hilmi?
Bisa ya.
Bisa ya? Oke, sip. Aurelia, when I give it for your quiz, did you answer it correctly?
Yes, think so, sir.
Okay, good. So this is how we solve it. Okay, and these are several other problem examples. Okay, you can use this as your practice. Okay, before the exam. Fast system shown in figure 3, subjected to the pull test with a pulley system like this. This is the pulley system to do the pull test. Okay, and the pulley is connected to joint M and K. The tension force is 100 Newton. And there is a pulling force 300 Newton here. So Q is 100 Newton. If Q is 100 Newton, then we can solve for the system of pulley here to find out for the forces there. So we can take a look at that. Okay. We have 100 Newton here. If we have 100 Newton there, this one is 100 Newton. Then we will have a, if we take a look at this first, okay. Then we will have a T here is equal to 100 Newton. Okay. And then what else there? And then we will take a look at this particular pulley, the smaller pulley. In the smaller pulley, if T is 100 Newton, this one is T equal to 100 Newton. Then this one will be 100 Newton as well. Okay, so if we this one, so we will go back and forth actually. T2, T1, T1. Okay, so this one we will have a T2 going up. Okay, and then we have the other tension here, T3. Okay, in that case, then if T1 is equal to 100 Newton, T2 is equal to 100 Newton as well, T3 will be using sigma Fy equal to 0, T3 will be equal to 300 Newton. Okay, because of that, the pulley K there, it will be 300 Newton over here. Okay, then there will be Kx and Ky. Ky, Kx. And there will be T here. Using sigma Fx, sigma Fy, sigma moment, we will be able to solve for T, Kx, and Ky. T will be 300 Newton. Kx and Ky will be later, if you calculate, it will be 300 Newton as well, each. Then we can solve for M. It will be 300 Newton here. T here, this one is T4, T5. T5 there will be 300 Newton as well. And beside that, we will be having Mx and My. After solving that, you will know that Mx and My will be 300 Newtons each. So at the end, you can solve for the free body diagram of the truss. There will be several forces there. Okay, there will be several forces there. And the first thing that you're supposed to do is to evaluate the zero force member. Okay, there are several zero force member here. You can try to use your knowledge on the zero force member, but based on this, based on the first analysis, I know that this one is zero force member. I know that this one is zero force member. This one is zero force member. Okay, because those four are zero force member, this will become zero force member as well. Hey, sorry, that one is not. This one will become zero force member as well. Okay, beside that, this one is zero force member. Okay, and because this 4 is zero force member, okay, this one will become zero force member as well. Okay, because this 4 is zero force member, this one will become zero force member as well. So you can see, right? There are a lot of zero force member over there. So basically, the problem can be simplified into this. Now it becomes very simple. The problem, sorry. This one is not zero force member because there is a P here. But MC is zero force member because there is no external force there. Okay. So later, our problem will become simplified like this. Yep. Okay, now it become like this, and like this. Okay. The forces now will become this one. P is 300 Newton. And then we have Kx, Ky, 300 Newton each, action and reaction. So it will be going to the left, 300 Newton, and going up 300 Newton. This one will be at M, action and reaction as well, going right 300 Newton, going up 300 Newton. And there will be AX, AY, and there will be EY. Like this. So now your problem will become like this. It becomes very simple. Okay. Remember, when you try to solve a fast problem, try to always take a look at which one is the zero force member. Always start with that. Okay. Any question about this particular problem? Now it becomes very simple, so you can solve it using join method, or you can solve it using solve it use a section method. The one in question is ML, OE, and DE. Okay, the last three is ML, OE, and DE. ML, this one. Okay, so this one, OE. Okay, so this one. Okay, and DE. So this one. Those three members. If the one in question is this, OE like this, the force at OE there, it will be the same as the force of this, ME there. Because MO and OE will be exactly the same. Okay, the same as DE. Okay, the force DE here. Okay, if that is the one in question. Okay, because we already simplify it. Okay, DE will be the same as CD, will be the same as BC, will be the same as AB, will be the same as AE. This one. Okay, same ML because LE is 0, so ML will be the same as LK, will be the same as MK, will be the same as this particular number. So basically, in the simplified case, you just need to find out these three values to solve for this. Okay. Any question about this? Apakah ada pertanyaan di sini? Silakan. Silakan, juga ada pertanyaan. Hugo Normano. Do you understand, Hugo? Halo, Hugo. Adam, Ahmad, do you understand, Adam?
Dikit-dikit, sir.
Dikit-dikit. Which part of it that you don't understand, Adam?
I think I understand. Just still trying to get it a little bit the other part.
Okay. Later, it's better for you to review it using the video. Okay. Okay. I think I will just continue. This is another problem example. Okay. For this one, I believe it won't be that hard. So basically, at A, is a 1000 Newton plate. So this one have a G of 1000 Newton. What else? There will be tension force here, T1, T2, and there will be normal force here. Okay, and at P, this one is P. Okay, there will be a tension force, T1, T2. Because here and here will be the same because the pulley here has no friction. Here and here will be the same because the pulley here has no friction as well. Okay, what else? There will be 400 Newton going downwards. And then there will be a normal force going downwards as well. Okay, because A is pushing B downwards, but B is pushing A upwards. That's the action and reaction. That's why the normal force here is going down. This one is going up. Okay. The one in question is N. Okay, the one in question is N. So using the first free body diagram, we have sigma Fy equal to 0 and sigma moment equal to 0. Using sigma moment equal to 0, what we will have here is T1 is equal to T2. Okay, and then using sigma Fy equal to 0, what we will have there is N minus 1000 plus T1 plus T2, but T1 is the same as T2, so 2T1 equal to 0. Okay, then we can use this to the second free body diagram. Using this equation, the same, we can use sigma moment equal to 0, and the result is T1 is equal to T2 as well. And then using sigma Fy equal to 0, what we will have there is 2T1 minus N minus 400 Newton equal to 0. Okay, we have two equations. We have two equations which has T1 and N, normal force, to solve for both. So we can solve for T1 and we can solve for N. Okay. The other problem, I already gave it to you guys as a homework. Okay, any other question about this? If not, then I will discuss a little bit about the frame. Frame will not be part of your exam. It will not be part of your midterm exam, the first midterm exam. Okay. I think in order to make it easier, I will divide the recording into two.